You've probably seen this. You ask an AI a question, and you watch it lay out its logic, step by step, almost perfectly. It really feels like you're watching a new kind of mind at work. But what if that whole performance, that brilliant reasoning, is just a really, really clever illusion? That's what we're going to dig into. So check this out. This is a classic example of what we call chain of thought prompting. You just give the AI a little nudge, something simple like, let's think step by step, and it unpacks the problem, showing its work. It's an incredibly powerful technique, and honestly, it's a big reason why so many of us believe these models can actually reason. And right there, that's the multi-billion-dollar question, isn't it? When an AI lays out its logic like that, is it truly understanding the concepts behind the words? Or is it just doing something else entirely? Something that just looks an awful lot like thinking? This is the core mystery we're unpacking today. Okay, so this is where things get really interesting, because for all its brilliance, this illusion of reasoning starts to show some serious cracks when you look closely. There are moments where the AI's logic seems to just short circuit, leading to this fascinating paradox. Yeah, it's a weird one. The model can correctly state all the facts, lay out a flawless-looking series of steps, and then right at the very end, it lands on a conclusion that completely contradicts everything it just said. Take a look at this exact example from a recent study. Researchers asked Gemini if 1776 was a leap year. Its reasoning looks perfect, right? It says the rule, it does the math, and concludes, correctly, that 1776 is a leap year. But then, in its final answer, it says the exact opposite, that it was a normal year. I mean, how does that even happen? It's not just a small error, it's a fundamental breakdown of logic. This is precisely the puzzle that a team of researchers at Arizona State University wanted to solve. It's not about the AI making simple mistakes. It's about this weird, fundamental disconnect between the process and the answer. And they had a really powerful hypothesis for why this is happening. The researchers basically proposed that maybe we're looking at this whole thing the wrong way. They suggested that instead of asking, is the AI thinking, we should be asking a different question. What patterns is it following? So here's their core idea. The AI isn't engaging in genuine abstract thought. What it's actually doing is playing an incredibly advanced game of pattern matching. It's just recognizing and stitching together these statistical patterns of text that looks like reasoning, which it saw over and over again in its training data. Now, to test an idea like that, you can't just use an off-the-shelf model like ChatGPT, because you have no idea what's in its massive, messy training data. So the researchers had to do something pretty clever. They had to build their own clean, isolated world to train an AI completely from scratch. They gave this custom-built world a great name, DataAlchemy. You can think of it as a framework specifically designed to be an AI stress test. It lets them see exactly what happens when an AI gets pushed outside the comfort zone of the data it was trained on. So here's how they built this simple little universe for the AI. Instead of the whole internet, it just had basic atoms, the letters A through Z. These atoms could form elements, like the word apple. And then there were transformations, simple, consistent rules, like shifting every letter forward by 13 places. This Lego-like setup gave them complete control over the reasoning problems. All right, so with this controlled AI gem all set up, the researchers could now systematically probe the AI's limits. They designed 3 really critical tests to see where this pattern matching would hold up, and more importantly, where that illusion of reasoning would completely shatter. First on the list, task generalization. Basically, what happens when you give the AI a problem that uses the rules it already knows, but in a combination it's never ever seen before? Can it apply its logic to a totally new situation? The results were, well, they were stark. On tasks that looked just like its training data, what they call in distribution, it scored a perfect 100%. But the moment they gave it a new combination of those same rules, an out-of-distribution task, its accuracy dropped to a flat 0. It couldn't generalize at all. The second test honed in on length. The AI was trained exclusively on problems that took exactly 4 steps to solve. So the researchers asked a really simple question. What happens if the problem is just a little shorter or a little longer? And again, it was a total collapse. For problems with that familiar 4-step length, the AI was perfect. But for problems needing just 3 steps or 5 steps, its accuracy plummeted straight back down to 0. The model hadn't learned a flexible reasoning process. It had just memorized a rigid 4-step dance. Now this final test might be the most revealing of all. It's about format generalization. This tests just how sensitive the AI is to tiny, superficial changes in how you phrase the question. Does it get the underlying logic, or is it just clinging to surface-level clues? The results here just scream brittle. With the format unchanged, performance is perfect. But add just a little bit of irrelevant noise, a few extra characters here and there, and performance falls off a cliff. Make a slightly bigger change to the format, and it drops to nearly zero. The AI isn't understanding the logic, it's just recognizing the sentence's shape. So when you put all three of these tests together, the failures on new tasks, new lengths, and new formats, a very clear picture starts to emerge. And it all points in the same direction, leading the researchers to a pretty powerful conclusion. And here it is, straight from the paper itself. Chain of thought reasoning, as impressive as it looks, is a brittle mirage. It's an illusion of intelligence that completely vanishes the second you push it outside the very specific patterns of its training data. It's not thinking, it's just incredibly sophisticated mimicry. Look, this isn't just some abstract academic finding. This has huge real-world implications. Knowing that what you're seeing is pattern matching and not true reasoning fundamentally changes how you should approach and use these powerful tools. So what can you actually do with this information? Here's a quick guide. First, just be skeptical. A logical-sounding chain of thought doesn't mean the answer is right. Remember that leap year paradox. Second, test the limits. Give the AI the same problem, but phrase it in a few different ways and see if you still get the same answer. And finally, and this is key, use it as a tool, not a thinker. It's a phenomenal pattern matcher, but be very, very careful trusting it with problems that are genuinely new.
And all of this brings us to the big final question. This study shows us the clear limitations of our current approach. It seems that just making models bigger and feeding them more data has given us an amazing illusionist, but not a true reasoner. So what's the missing piece? What's the breakthrough we need to go beyond this brilliant mirage and build an AI that can genuinely understand?